Hello and welcome to Algebra 1, and today we are starting Chapter 9. So Chapter 9 is called Quadratic and Exponential Functions, and this lesson will be over 9.1. So 9.1 is graphing quadratic functions. So I've been mentioning quadratic functions a lot in class lately, and I want to bring up again the standard equation for a quadratic is this has an x squared in it. And so if something is in this form, this ax squared plus bx plus c, it's called a quadratic, and it graphs what's called a parabola. So down here in the bottom right hand corner you can see what a parabola looks like. And I know this isn't on your notes, but just wanted to mention there are lots of real-world uses for parabolas, and probably the greatest use of them is in trajectories. So if something is being launched, something's flying through the air. And so this case we have a rocket that's being launched, and so its path will be in the shape of a parabola. So we are wanting to graph these. Okay, so these are functions in this form, so let's make sure we have that written down. That's the standard form for a quadratic. And their shape is called a parabola, and parabolas can open up or down. Now in most real-world situations they're going to open down, like the second picture here, because gravity kind of brings you back to Earth, so we have it like that. But they don't have to. They can open up or down. And the way that we're going to start out by graphing these is with a table. So our directions are to make a table of values, to graph y equals x squared plus 3, and then we're going to state the domain and the range. So we're going to start out with our xy table, and a great x to start with would be 0. And so if the question is, well, what is y when x is 0? And so we need to figure out what is 0 squared plus 3, and that is 3. And I like to graph as I go, so I'm going to put a point at 0, 3. And then let's maybe plot 1. So we have 1 squared plus 3, which is going to be 1 plus 3, so we get 4. Okay, so we get 1, 4. And what you need to do is you need to do as many points until you can find the turning point, which is called the vertex. And we need a few on either side of the vertex. So that's 4 plus 3, which is 7. Okay. Now, if I do even bigger numbers, where is this going? Is this going to keep getting bigger? It will, because we're squaring the number we're putting in. So let's come to the other side of the y-axis and try -1. And this is where you need to be really careful with your calculator, and you need to put parentheses around any negative numbers, because -1 squared is a positive 1. Okay, so I get 4. So that tells me that 0, 3 was my vertex, or my turning point. So I said I wanted my vertex and like 2 points on either side of it. So if we do -2 squared, so -2 squared is a positive 4, plus 3 is 7. Alright, so when you go to draw this in, it comes down and is nice and rounded. It does not come to a point. Alright, so there's our graph. And then for our domain, is this going to go left and right forever? Can I put any x's in there? I can. So the domain is all real numbers. For the range, does it go to every single y value? It doesn't. In fact, all of these y's, it doesn't even hit. So y has to be greater than or equal to 3. That was its lowest y value that it hit. Alright, so let's try another one. So table of values, and I would start with 0. So we get -2 times 0 squared plus 0 plus 1. That's going to turn out to be 1. So I get a point at 0, 1. And then I would put in 1. Alright, so that's going to be 1 times -2 is -2. -2 plus 1 is -1, plus another 1 is 0. So 1, 0. Okay. Let's try 2. All right, so in this case, this is going to be 4 times negative 2 is negative 8. Negative 8 plus 2 is negative 6, plus 1 is negative 5. And this is where on the last one we went ahead and went to the other side. So let's try negative 1. And you can enter these into your calculator as long as you really make sure to be careful with your parentheses, or sometimes I think it's just as easy to do them in your head. Negative 1 squared is a positive 1. So there's 1 times negative 2, which would make a negative 2. Negative 2 minus 1, or negative 2 plus a negative 1, would be negative 3. Negative 3 plus 1 would be negative 2. Alright, so then what we can see is that, they should be symmetric, and so something is happening on one of the sides of 0. Let's go ahead, let's do negative 2 here, and then we'll come back and address that. So negative 2, so there's going to be 4 times negative 2 is negative 8, negative 10, negative 9. So when you graph a parabola, you really want to know where is its vertex, where's this turning point. And so, we really need to examine this area in here to see, okay, what side is this turning point on? So I'm going to extend my table, and let's do negative a half. And I'm just actually going to type it into my calculator real quick. Negative a half is at 0, so I know we have this point right here. Okay, so then what about positive a half? And there's this times, so that's 1, that you just really have to kind of play detective and figure out, well, where is that vertex? Okay, well, at 0 and at a half, they both were at 1, so I'm going to bet you that it's halfway between those, which would be at a fourth, and a fourth is at 1.125, which is 1 1/8. It's hard to tell that's above there, but it's above there. So there is that parabola. So it works out so nicely when they have like a whole numbered vertex, but that's not always the case. So here's the deal. We're going to do one more example now, and then I'm actually there's going to be a second part to this video. You need to watch both parts, and we're going to talk about, well, there has to be an easier way to find this vertex other than just a guess and check of numbers. So let's do one more example now. Let's domain, all real numbers. It's going to go left and right forever. Range, y's that are less than or equal to 1.125, which is a good thing that we found that number then, because otherwise we wouldn't have that specific value. Alright, so our last one, we have a real world example here of this represents an arrow being shot into the air where y is height. So y is height. And x is time measured in seconds. Height's measured in feet. And so notice, I wrote those on my graph. We don't typically write them on the graph, but in a case like this, you're really just looking at the first quadrant. So we need to make a table of values, and I'd start with 0 and get 4. Okay, and then I would put in 1. And I'm going to plug this into my calculator again. Actually, let me plug it in and then I'll say something about it. And you should be trying to plug these in too, making sure that you get the same numbers. For 1, I get 9. Be really careful with that negative sign, because this needs to be negative 1 squared plus 6 times 1 plus 4. That negative doesn't get squared, so you square your value for x and then you tack on the negative. It's a really common mistake, but order of operations says that this is multiplying right here, and you have to do your exponent before you multiply. So we're going to go ahead and plug in 2, and 2 gets us 12, and then I have to apologize for not getting you a big enough graph. Do make sure that you are getting these values. 3 I get 13, 4 I get 12. All right, so 1 is 9. 2 is 12, 3 is 13, 4 is 12. So this is coming up and back down. Okay. So mathematical domain and range of this function. So for the actual just equation, this is going to come down this way, this is going to come down this way. Your domain is going to be all real numbers. We're going left and right forever. Your range is going to be y's that are less than or equal to 13. So that is for the actual function. Now if we just said, and I didn't put it on here, but if we said reasonable domain and range for this situation, what we would probably want to do though is continue our table. Let's see here, 13, I bet you it's actually coming down at 6. Let's plug in, nope, 6 would be 4. 7 would be -3. So 6 is 4, 7 is -3, so it's actually coming down like this. So reasonable domain would be 0 less than or equal to x. We'll just say less than 7 right now because we don't know that exact value. Range is going to be 0 less than or equal to y less than or equal to 13. Okay, because we're not going to have a time that's negative, so we're just going to do our positive times here, and then our range, just the ranges that we went to. All right, that is the first half of 9-1. There is another video you need to watch. I just split them into 2 because they're a little bit different in terms of direction they're going for graphing parabolas. So watch the other one. Let me know if you have any questions. Have a great day.